use headphones for best experience. Thanks for your fantastic support. Hi, welcome to another video. First, let me show you that you can find a lot of my content audio only from audio streaming platforms like Spotify, Apple Music, or other platforms, and you type in ASMRctica ASMR, and you can check a lot of different albums here with the audio from my videos. Today I want to do a video about astronomy, and I'm still preparing for a drawing video, but I thought that this stage of the process could be nice to film as well. It's about asteroids, and I will zoom in so you can read this little text. So I'm trying to compile a lot of facts about the asteroids on these lists that I found on Wikipedia. And I already finished some of these. This is my new folder about astronomy, with information that I have collected from internet. List of solar system objects by size. Objects with radii over 400 kilometers. That's the planets. And some moons as well. Then here is the list of solar system objects smaller by mean radius, 200 to 399 kilometers in radius. The largest asteroid that is also a dwarf planet is Ceres, so it's here on the first list. It's more than 400 kilometer radius. As you can see, it's 469. It's a C-type asteroid. And it has an eccentricity of 0.08. It's not so much. And an inclination of 11 degrees. It's located in the middle Main Asteroid Belt at a distance of 2.77 astronomical units from the Sun. And it has an orbital period of 1,680 days. And here on the next list we have Vesta, the second largest asteroid. Or largest if you just consider Ceres to be a dwarf planet instead of an asteroid. And I like to add the diameter and not just the radius, because I found it more intuitive to think of the diameter of an astronomical unit, astronomical object. So I want to add like double the radius, so it becomes the diameter. And I add some additional information here. So I've already done this page here, and this page, and these rows in pink are the asteroids from the asteroid belt, main belt asteroids, and that's the one that I'm focusing on now. So where was I here? Io was the last one I did. And now it's time for Minerva. I check the Wikipedia page for Minerva. So it says here the mean diameter is 154 kilometers, or 156. Diameter 1,5. I'll go with 154 because I could see that the radius was 77 in this list. It's not super accurate how they measured the radius and diameter, so it differs a lot. Different measurements, or not a lot, but there are some differences. So sometimes I just have to pick a number. Here it says it's a C-type asteroid, and I've written C here in red, so it becomes more clear. It's a trinary also. In a system of asteroids, 3 asteroids like rotating together. And the semi-major axis for this one is 2.76. Astronomical units. So 2.76 astronomical units puts it in the middle main asteroid belt. And the eccentricity of Minerva, let's see what it is, 0.14. And the inclination is 8.6. degrees. The orbital period is 1,672 days. 4.58 Earth years is that. The next one is Alexandra, another C-type asteroid. Number 54, Alexandra. 54 indicates it was the 54th first discovered asteroid, I think. And dimensions here on Wikipedia. It says mean diameter 154 kilometers. And the semi-major axis 2.71 AU, and an eccentricity of 0.20, and an inclination of 11.8, and round up to 12. Orbital period 1,632 days. And just like Minerva, 2.71 astronomical unit, but sitting in the middle belt. The middle part of the main belt, so very much in the middle. Next one is Laetitia. Number 39. Discovered in 1856. So in the mid 1800s they started to discover quite a lot of them. It has a semi-major axis of 2.77. Also in the middle main belt. The diameter, mean diameter, it doesn't say here, so I can double the radius probably. 77, 154. I hope that's 77 times 2. The eccentricity of this orbit is 0.11. And the inclination is 10 degrees. Orbital period 1,683 days approximately. It's an S-type asteroid, a stony asteroid, or silicaceous. So yeah, basically made of rock. That's a type you would most likely find in the inner part of the main belt, or yeah, more close to Mars than Jupiter. And it's the second most common type after the C-type that you find more likely in the outer parts of the belt. The carbonaceous ones with a lot of carbon and organic materials. These are also very dark. These are more bright, more easily to detect the S-type. Or you have to find them like a bright spot. Next one is a G-type asteroid. It's called Can you read it? It's so tiny. Nemosa. Asteroid number 51 has a mean diameter of 150 kilometers. If you take that 0.6 times, you have the value, the number in miles. The semi-major axis is 2.37 AU. Eccentricity is 0.07. So this is a small eccentricity. Not as small as Earth's eccentricity, then it's 0.02, which means it's almost a perfect circle, its orbit around the Sun. So the closer to 1, the more elliptic is the orbit. The eccentricity doesn't have a unit. It's just a number between 0 and 1 in this case. So 0 is the perfect circle, but no orbit is a perfect circle. It's always a bit elliptical, so the more elliptic it gets, the more it varies its distance from the Sun. So the Sun is here and it's a very high eccentric orbit, then it goes like this. So in perihelion it's called when it's closest to the Sun here, and then aphelion when it's farthest from the Sun. And then when you take the mean, the semi-major axis, it's kind of a mix, or like a middle of those. Because then you measure the ellipse. You take the center of the ellipse instead. So it doesn't really describe how far it is from the Sun. It's just the middle value. When it's high eccentricity, it varies a lot, its distance from the Sun. So you could see 0.2. Quite. Of these, it's the one with the highest eccentricity. And also it has quite a big value here in the inclination. How it's inclined, how the angle is with the orbit, with respect to the plane, the solar system plane. Or the planetary disk. Well, they're basically orbiting in the same disk. Most of the planets, and the Earth's inclination, I think, is defined by 0 degrees, and then how much it differs from the Earth's angle. So yeah, it's not exactly in the plane, none of these. The inclination value here is 9.97. So I'll write 10. The orbital period is 1329 days. And since this value is less than 2.5, I'll count it as an inner main belt asteroid. Next one, Kalliope. I have read something about Kalliope. I recognize the name. Wonder if it's one of those with the moon. Yes, known satellites 1. So it has one moon. Linus, it's called. Yeah, it also says here binary. A binary asteroid. Yeah, it would be fun to check if how much smaller the satellite is. Venus moon is 28 kilometers. And Kalliope's diameter is 150. There are a lot of values here, but I'll just pick one. 150. So yeah, the moon is much smaller. But I think because it has a moon, it's called a binary system of asteroids. Also here it was a trinary system. Minerva. So the distance from the Sun, or the semi-major axis, is 2.91. Which puts it in the outer part of the main belt. Not very far out, but since it's after 2.82, or I mean further out than 2.82 AU. But let's see the eccentricity. It's 0.10. So for example here, when it's 2.91 AU, the semi-major axis, and it has an eccentricity of 0.10, you can check here the perihelion. When it's closest to the Sun, it's actually 2.6. That's considered in the middle main belt actually. And when it's in its aphelion, farthest from the Sun, it's 3.2 astronomical units from the Sun. So then it's definitely in the outer parts of the main belt. Almost at the rim of the main belt, actually. After 3.27 AU, then it's considered Cybele asteroid. It's not considered one of the main belt asteroids anymore. So this makes me wonder if it's correct to call it an outer main belt asteroid after all, because sometimes it's in the inner part. But I'll just compare the semi-major axis here when I decide if I put it in the inner, outer, or middle. And the inclination of the orbit is 13.7, so I'll write 14 degrees. And the orbital period is 1,814 days. And that's almost 5 years. So since this is the one in the most outer part of the belt, you can also see its orbit is the longest counted in days, because that's always the case. The orbits are how fast they orbit the sun is decided by the semi-major axis. Yeah, the size of the ellipse. I think, I'm not sure actually, because maybe the eccentricity also plays a role here, of course. It was an M-type, the third most common type of asteroids, the metal ones, very dense, consists basically of a lot of metal-rich stone, metal-rich rock. Usually it consists of a lot of iron and nickel. Next one is Pallas, not Pallas, but Pallas. It has a mean diameter of 150 kilometers. It has a semi-major axis of 3.10 AU. So that's definitely in the outer parts of the main belt. The eccentricity is 0.23. High eccentricity here. And outer belt, is it here? Not outer belt maybe, but outer part of main belt. And the inclination is 3.2 degrees. Orbital period 1,995 days. The next one is a stony one, S-type. Parthenope. First discovered asteroid, discovered in 1850. With the mean diameter of 149 kilometers. With a semi-major axis of 2.45 astronomical units. An eccentricity of 0.0 0.1. To be more exact. 2.45 puts it in the inner parts of the main belt. S-types usually more common in the inner parts of the belt. An inclination 4.6 degrees. An orbital period 1,403 days. Or 4. 1,404 days. And next one is 95 Arethusa. With a diameter of 136 up to 147 is the values here. I'll put I'll write 147. And let's see where it's located in the solar system. To the semi-major axis of 3.06 astronomical units. It's in the outer part of the main belt. It has an eccentricity of 0.15. And inclination of 13 degrees. Orbital period of 1960 days. Or 5.36 Earth years. So the asteroid belt, or belts, if you divide them into inner, outer, they are located between Mars and Jupiter. Mars and Jupiter's orbits. The Mars orbit is at 1.5 astronomical unit from the Sun. And Earth is 1 astronomical unit from the Sun. That's how astronomical unit is defined. The distance between the Sun and Earth, 1 astronomical unit. So the Sun is here, then 1 astronomical unit away is the Earth, 1.5 astronomical units away is Mars, or the Mars orbit, of course. Since they are orbiting, they're not always, they are rarely found exactly in a line like this. So here there are also some near-Earth asteroids, but there are not so many, or maybe there are, but they're very small and not so many have been detected. If you compare to the main belt, that starts basically at 2.06 or at 2 astronomical units away. Starts, and then the main belt stretches out to 3 astronomical units, approximately, or 3.27. So Earth is 0, Sun is 0, Earth is 1. Inner part of Main Asteroid Belt is 2, and outer part of Main Asteroid Belt is 3. And between Earth and inner part of Main Asteroid Belt at 1.5 is Mars orbit. And at 4 astronomical units away from the Sun is an area with, there are still asteroids there, but there are some, I think maybe the Hilda group is here. It's definitely not part of the main belt. It's very scattered, but there are objects here as well. And then at 5 astronomical units we find Jupiter's orbit and Jupiter's Trojans as well. It has its own asteroids following Jupiter's orbit, the exact same distance from the Sun. And that's all the asteroids. An asteroid is definition is that it has to be in the inner solar system, so more far out from Jupiter it's not called an asteroid anymore. It's called a centaurs, between Jupiter and Neptune, I think, and then further up than Neptune it's called trans-Neptunian objects or Kuiper belt objects. But it's basically the same type of astronomical unit, or there are a lot of different types, but they are mixed. So even in the main asteroid belt you can find objects that are looks more like an it's coming from the inner part of the solar system, and some objects looks more like, are similar to the trans-Neptunian object. So they have probably back in times when solar system was formed, they have probably moved from one part of the system to another. So they most of them kind of ended up here in the main belt and in the Kuiper belt, but it has definitely to do with Jupiter. That Jupiter is so huge planet and has so strong gravity effect, gravitational effects, so they kind of ended up there, and maybe also no proper planet could form in that area so close to Jupiter, even if it's not super close. I mean, it's 2.5 astronomical units from the Sun, compared to 5 astronomical units, Jupiter's orbit. So, but I mean, it still has a very big impact on those objects. The next one, Pulcova, number 762. So this one must be discovered. Have been discovered later. Yeah, in 1913. This one was discovered. It has only set radius here, so I'll double this value. 74,100. And okay, it says actually on Wikipedia here mean radius 68.5. So 69 times 2 is, what's that? 138. Because I wanted the value to be smaller than this one, since these are listed in by size. But yeah, like I said, it changes from observation to observation. It differs quite a lot. What value you find when you try to measure or estimate the size of these objects. The semi-major axis is 3.15. So we are in the outer part of the main belt again. Eccentricity is 0.10. And the inclination is 13 degrees. Orbital period 2047. 5.6 years. I think I will go on now and just write and not to